So today we're going to be talking about our quadratics again. We're still going to be talking about multiplying our polynomials, finding the zeros, finding the maximum, the minimum, finding the y-intercept, and the domain and the range. So we're continuing to add to some of the things we've already done. I am going to be flipping back and forth just a little bit as we look at this. And that is because I want us to be able to see everything that I'm looking at. I don't have enough room on this page to be able to accommodate everything that's on the front of the page that's in front of you. So as I flip back and forth, it's just to go between the bottom of the page and the top of the page, okay? Don't forget, when you're looking at a domain and a range, finding the limits of the graph, it's what's important. This line that I'm drawing right here, it's got a dot on each end that sets what the limit is up and down, and also the limit left and right, and says, okay, these are the only places that that graph can go. On the quadratics that we've been talking about curves that go down like that and open upwards, or curves that open downwards like this. On each of these, you're going to notice that there is a minimum or a maximum that is setting a limit on how far up or down the graph that it goes. Don't forget that when we're looking at going up and down the graph, that is a part of our range. In most cases, when you're graphing a quadratic function, your range is going to be limited either in the up or down direction, but your domain, the side-to-side motions, are going to keep going forever. What we're going to do now is we're going to be flipping back and forth with our same equation that we have up here, and we are going to be finding the zeros, the vertex, and all that stuff, okay? So to begin with, if we're looking for our zeros, we're going to, and I would write this off on the side, not in the middle, take our negative x plus 1. That's our first part here at the top. That's the first set of parentheses here. We're going to set that equal to 0. And we're going to solve for x by minusing 1 on both sides. Negative x equals negative 1. When we multiply by negative 1 or divide by negative 1, whichever way you want to think about it, it accomplishes the same thing. You find out that x equals positive 1. That positive 1 that we're talking about there is the x value of our 0. The y value is the 0 part of the 0 that we're looking for there. So when I go to write this, it is going to be parentheses 1, 0. That's going to be my first 0. Don't forget, there's two sets of parentheses up here that I'm going to have to solve for. The second one is that negative x minus 3, and that negative x minus 3 can be set equal to 0. And then by adding 3 on both sides, you get negative x equals 3. Again, multiply or divide by negative 1 on both sides, and you find out, oh, x is negative 3. So I run over to this side and I go, okay, the x part of this is negative 3. The y part is the 0, and that's why it's called a 0. And we are good to go. Now, in order to find the vertex, we're going to want to go ahead and multiply these two polynomials together. The way that I've been showing you how to do that is by either using the FOIL or the box method. It kind of depends on which way you're most comfy with. I know that for most of you, you've been doing the box method, and I happen to really approve of that. So let's go ahead and set up our boxes and go from there. One of our boxes is this negative x plus 1 and our negative x minus 3. Don't forget, we are going to be multiplying into each of these boxes, and I'm going to change color to show which terms go together. Negative x times negative x is x squared. Negative x times positive 1 is negative x. Negative 3 times negative x is positive 3x. And then last but not least, negative 3 times positive 1 is negative 3. And because I'm looking at these two x's here, the 3x and the negative x, they don't have exponents, and they don't have just the constant by itself. They both have just the x. Those can be combined together. So my equation here is going to be y equals the x squared I've got plus the 2x that I get from 3, take away the 1x there. And then the minus 3 at the end just gets tacked on with the minus 3. I'm going to be able to say that's my equation, and it happens to be what I've got here. From there, I'm going to be able to take my calculator. Excuse me real quick as I get my camera open just now. Camera. Yay. Ugh, I hate when it turns on like this. I apologize. But we can get this typed in and we can figure out what the maximum, the minimum, and all of that are by looking at our graph. I hate that these calculators take forever to load up like that. Okay, so once this turns on, we're gonna go ahead and clear out of the press to text mode by pressing enter when that screen comes up. From there, we're gonna be pressing B because we're gonna be going to graph, okay? Come on, come on, come on, come on, come on. This thing, I swear. Let me try to figure out another calculator and see if that works any faster. It does. Okay. So yeah, press enter to clear the press the text, press home, B to graph, and then we're going to type in what we had from above, the y equals, and we said it was x squared plus 2x, and then we were going to subtract the 3, and then we can graph it. And we can see that there is a minimum on this at this point. We're actually going to take that and we are going to be graphing it on here. Okay? Sure, there is a minimum. And the question is, where is that minimum? If we go back to our calculator, we can say, okay, menu, table for 7, 1 to show the split screen table. I've got my table here. And again, I'm looking at these numbers and saying, at what number does it actually stop going down? And I see -1, -4. That's that point there. I've also got my zeros at -3. I've also got my other 0 over here at 1. So that makes sense to me. All right, so let's go ahead and take this information and start plugging it in. The vertex that we were talking about at -1, -4 is the minimum, and that goes onto this graph here. Then I've got my zeros at the 1 and the -3. And then I also saw that at -2 and at 0, I had another perfect point that we could go with, and that's going to draw this graph here. So when I look at the domain and the range of this, the domain never stops going to the side. It'll always go to the right and to the left. It'll just go really, really high as it goes farther to the left or to the right. And that green line that I drew at the bottom there is going to limit how low down this graph that curve goes, okay? So the domain, still calling it all real numbers, is perfect. For the domain, it's almost always going to be all real numbers for this kind of thing. The only time it's not going to be is, the only time it's not going to be is if there's no arrows up here. If instead of arrows, you had dots at the end. That would be the only time that it would be limited, because then it wouldn't be able to go all the way to the right or all the way to the left. There would be a set point. But yeah, what we're looking at here is still going to be arrows that go off in those directions. The range that we're talking about here is going to be how far up it goes. Well, it can always go up. It just can't go below -4. That means as long as your y is bigger than or equal to -4, because remember, it could equal -4 here, that you're going to be okay. This is going to be what my domain and my range is. All right. So what I'm going to go ahead and do is I'm going to have you take your papers and I'm going to have you finish up the other 2 questions on the back. I will come check those, and then I will have you work on your worksheet.